Hi friends from OpenCore. Today we're going to show you a recent study about biomechanics of tennis that could bring us some interesting new findings. Sports biomechanics is a widely studied field inside biomechanics, as it can help optimize the sportsman's performance and prevent the risk of injuries related to certain movements. In many individual sports, just like in tennis, the success depends on the good equipment, luck and training of the athlete, but also, and more importantly, on the sportsman's technique. By using biomechanical studies, different techniques can be compared and studied, in order to determine the more optimal ones, as well as the ones where the player can take advantage from its opponent. So today we've come to Barcelona, where the latest study about tennis biomechanics has been developed by two biomechanical engineering students. We've been talking to them, and we have the luck to know more about their recent findings, so let's go inside.
So, hello everyone, and thank you for inviting us to your program. The main objective of our project was to analyze the data of free tennis motions. These motions were captured at CREP, which is the Centre de Recerca en Enginyeria Biomèdica, and it is located at ETSEIB, Barcelona. So basically, the main goal of our project was to properly understand the free tennis strokes, which are forehand, backhand and serve, and they are the most used strokes in a tennis match. So this data can help us to prevent players' injuries and also strengthening and training the human parts of these areas that are most used. Furthermore, the data we obtained was compared with data of other published papers with the aim to validate and extrapolate the conclusions of our study.
The data used in the study was recorded by previous students in the ETSEIB biomechanical laboratory. 60 markers were placed in several parts of the upper body of a subject. Then, using the software OpenSim, a kinematics and dynamics analysis were extracted. In order to study these three drives, an upper body skeletal model with 16 degrees of freedom was used. The process starts by scaling the model in order to correspond to the subject and then reduce errors. In this step, the mass was modified and the markers were adjusted. The second step was to perform inverse kinematics to the model with the recorded motion, a process that estimates the coordinate value for each frame of time. Finally, an inverse dynamics analysis estimated the forces and moments.
For the forehand drive, the instant when the ball was hit corresponds to approximately the 70% of the cycle, and consequently the joint maximum values of angle, displacement, movement and speed are located around this point. This strike also is almost a transverse plane movement. So now for the backhand movement, we have some similarities to the forehand, as for example the swing of the arm is executed relatively horizontally over the transverse plane. However, in this movement there is the intervention of the left hand, which might cause the movement of the right hand to have lower values. Also, the impact with the ball occurs at around 75% of the backhand cycle. So finally, for the serve strikes, this strike appears to be most different in comparison with the previous ones. First of all, the arm starting position is completely vertical at the impact with the ball, and its movement is on the sagittal plane. Therefore, there's a substantial variation in our data with this movement and the previous ones. And also the contact with the ball is around 30% of the whole cycle.
So, after analyzing the data, the research group arrived to some interesting conclusions. With a quick look at the plots and results of the study, it can be stated that the serve stroke is the one with higher values and larger joint involvement. As it was mentioned before, this stroke differentiates from the other two as it mainly executed on the sagittal plane. So, as a major trait of each of the movements, it was concluded that the forehand is the one with major pronosupination speed, where the wrist has major action from the three movements. Then the backhand was the one that has least affection of each of the joints. And then finally the serve is the one where all the actuators, all the joints have major implication during its strike. So the second part of the study was to compare all the data they gathered with other studies. The first article they compared with was an article from 2009 where a group of researchers studied the biomechanics of the tennis serve.
So the data of our subject has been compared to this published study, and we found out that only one joint rotation speed during the first tennis serve matches the interval settled by this literature, and also the elbow extension speed is far lower than expected, and all the values that impact are also considerably lower than in the literature. But however, knowing that the subject didn't use a real tennis ball and he wasn't at his real match atmosphere, we believe that he might have been affected, and so his performance was lower in impulse and force than it would have been in a real match. We also believe that given the big differences between our subject and the literature, we think that our subject might not be a professional tennis but just an amateur one.
The second study target in this work was about the intersubject variability of the angular kinematics of the wrist and elbow joints in the tennis forehand drive. Their main goal was to compare the data of the forehand drive of the subject they studied and see if his performance was similar with the Big Ten varsity tennis players. The data studied is the wrist angle variation and velocity and the elbow angle.
So for the elbow angle, we can see that our subject has similar shape values as the ones in the article. However, for the wrist angle variation, we see that in the literature the movement starts decreasing its angle, and when it is reached its minimum, there's a small peak before going up again, and this small peak is not performed by our subject, even though the rest of the shape is similar. And so also the peak speed corresponding to the missing angle peak does not appear at the speed figure as expected. However, as said before, the same angle shape can be seen with the speed increasing at the angle as the angle decreases. So the values of either angles and the speed variations are lower for our subject than for the ones in the literature, and this might be explained similarly as for we had said before for the serve. So as we said, the subject was not using a real ball and he doesn't seem to be a professional player.
By knowing some of the information of this study, players can focus on the parts of the arm that require major training and that can get easily overloaded during a match. But also, it can help players to push their opponents to certain types of game, where they can wear them out faster. Hope you enjoyed today's program. See you next week.